Today we'll start with class 10, application of trigonometry part 2. So we already have seen the introduction part. Let's start solving this one. So this exercise 9.1. Coming to exercise 9.1, question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. So we find that there is a boy who is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. So from this we understand, once we read the question application of trigonometry, you all know that first we have to draw the diagram. Also identify the objects. So here we can see there are two objects. One is a tall boy and one is a building. And the distance between the boy and the building, here so there is, he is standing at some distance, is not given. This 30 meter is the height of the building. So once we identify the object, let's start drawing here. So I'll draw first a building and a 1.5 meter tall boy. So here we can find a boy is there. So here, let's take a straight line. So let's draw a tall meter. So there are only two objects we have identified. One is a building and the boy. I will draw the ground level also. Okay. So in the exam also, I request you please draw neatly with using scale. So here we have drawn the distance between them. Okay, let's try to read more. So here it is given 1.5 meter tall boy. So let's assume that to be AB. Okay, I'll write afterwards. And CD is the building. CD is a building and AB is a tall boy. And here the height of the boy is given as 1.5 and the height of the building is given as 30 meter. Now what do we observe? That the angle of elevation from his eyes. Elevation means the person is raising his head. So let A be the point where the boy is there. Okay, boy's eyes. Now he is raising his head to see the point C. And the angle of elevation formed is first 30 degree. Okay, and then to 60 degree as he walks towards the building. So for drawing the angle of elevation, we all know we need horizontal line. So let's draw first the horizontal level, which I am drawing in the pen. Now let's draw the angle of elevation from A to C. So when you draw angle of elevation from A to C, here, the angle of elevation formed, that is from A to C. So first, the angle that is formed is 30 degree. Now, it is given that the elevation increases to 60 as he walks towards the building. So that means the boy, when he walks towards the building, the angle is increasing. If he walks more towards, the angle will always increase. So remember, when we go close to any object, that particular object, the angle will always increase. So let's assume that the boy has come closer to the object and now the distance between them, that is now the angle of here. Let's assume the same boy has come here and we will assume this to be PQ, the distance. So this is AB, this is PQ. And now in this case, the angle of elevation that is formed from P to C. The P to C, the angle of elevation increases, that is 60 degree. Here. Here we can find now this angle of elevation has become 60 degree. Correct? I'll just make more closer. So here we find that the angle of elevation is 60 degree. So let's understand the sum once again. So here I'll just rewrite it. So this is students A, B and C. So let's understand the figure whether we have done it correctly or not. So a 1.5 tall boy, so this is AB is a 1.5 tall boy, is standing at some distance from a 30-meter tall building. So CD represents the tall building, so we can say here tall building. AB represents the boy, so we have written 1.5. The angle of elevation from his eye, so this is the eye position. He is raising his head up to see the top of the building. From his eye to the top of the building increases from 30 to 60 as he walks towards the building. So the first angle of elevation is 30 degree. Now the ball AB has come to a different position. So we have named the position of the ball is PQ. And when he comes closer, when he walks towards the building, and now he sees to the same top, the angle of elevation increases to 60 degree. We have to find the distance he walked towards the building. So how much distance he has walked towards the building, that is BQ, we need to find out. I think the diagram is very clear, and this is 90 degree on. This will also be perpendicular as we always draw horizontal level. So here we have, once we have drawn angle of elevation, we have to draw, or angle of depression, any angle, we require line of sight and horizontal level. So AE here is the horizontal level, AC and PC are nothing but the line of sight. Now this I have just written for information, otherwise it's not necessary. So when we go for writing the solution, the minimum information which you are supposed to write is we can write AB equal to PQ, that is 1.5 meter. We have that CD is nothing but 30 meter here. We can also add ED is also 1.5. Can we say this is 1.5? Yes. So can we find CE? So CE can be found out very easily by saying CD minus CE, that is 30 minus 1.5. So here this is 30 means 30.0 minus 1.5. So 10 minus 5 will give you 5. 9 minus here carried, so 8. So here we have 28.5 meters. Now our aim is to find what is AP, or we can say BQ. So we have to consider two right angle triangles here. We can say first right angle triangle is AEC. So once we draw the figure, we have to identify the objects and draw the figure correctly. We have to identify the two right angle triangles involved. So after identifying the two right angle triangles, the common side involved here is CE in both the right angle triangles. There is first right angle triangle is CEP, the other right angle triangle is AEC. See, AEC is the first right angle triangle, CEP is the two right angle triangle, which is a common thing involved, that is CE. Then we have to identify this trigonometric ratio and what we have to find. Now we know that we have to find AP. So this is related, this is AP's along AE. So we can find AE, we can find PE. AE can be found out by using this triangle, AEC, and we can find PE by using this triangle. If you subtract A minus P, we will get AP. Now which trigonometric ratio we have to use? This is a given angle, this is a given side. So this is opposite and this is adjacent. So obviously we will use tan. So let's start solving. So let's take first in right angle triangle. If you consider the smaller triangle first, CEP. So we take tan 60 degree equals to opposite is CE upon PE. Tan 60 degree, you all know it is 30 degree. CE is 28.5 upon PE. So we get PE equals to 28.5 upon root 3. So we can rationalize the students by multiplying with root 3 and root 3. So we'll get 28.5 root 3 upon 3. Sorry, here it's not root 5, it is 28.5. Can we cancel it? Let's see, 8 2 plus 8 10 plus 5 15. So it follows the rules of divisibility of 3. So we can cancel 3 9s are 27, 1 3 5s are. So here we are getting 9.5 root 3. Let's consider the second right angle triangle. So in right angle triangle, I am following the same. You all just write down, since here in the whiteboard I am trying to utilize so that I can utilize the diagram. In right angle triangle CEA, tan 30 degree equals to CE upon AE. Tan 30 is 1 upon root 3. So CE is 28.5 and AE we have to find, right? So we will get AE equals to 28.5 root 3 when we cross multiply. 1 into AE, 28.5 root 3. What is our aim? Our aim is to find what is AP. Therefore, AP equals to AE minus PE. What is AE? 28.5 root 3, and here we got 9.5 root 3. Sorry, here root 3. So we have root 3. I'll just write little clearly. So here we have, students, 28.5 root 3 minus 9.5 root 3. So here we have, this is root 3. So root 3. So here we have root 3, 5 will cancel 0. Here we get 19. So the final answer is 19 root 3. At the last, don't forget to write the final answer. The distance he walked towards the building equals to 19 root 3 meter. I hope this is clear. Let's go to the next sum. That is question number 7. Again, whenever you have a new sum, try to find out the objects and then you will recognize them. From a point on the ground. So this is one keyword, from a point. The angles of elevation of the bottom and the top of a transmission tower. So we have a transmission tower fixed at the top of 20-meter high building. 45, 60, find the height of the tower. So we have, there are 3 objects here to do from a point on the ground, and there is a transmission tower fixed on the top of a 20-meter high building. So let's take our scale. So here, let's draw first, okay, I'm sorry. One sec. So I will take the scale. Here we will draw first the building. Okay, so exactly 90 degree vertically I have taken. So a building. Okay, this building has become too long. Okay, I will just name this as that from B, AB, let's take as a transmission tower, and let's take this BC as the building. BC is the building and this is the tower. Okay. Now there is a point on the ground. Let that point A, B, C, D. Let's take D. So from a point on the ground, let that point is D. The angle of elevation of the bottom and the top of the tower. So angle of elevation of the bottom and the top of the tower fixed at a 20-meter high building. So this is 20 meter. That is from here to here. Are 45 and 60. So the angle of elevation of the bottom from a point on the ground, that is to the bottom. So first for the bottom, here the angle of elevation is 45 degree. Okay. So I'll use my scale and draw first 45 degrees, that is from D to B. Okay. So once you identify the figure, D to B, we have to draw the angle of elevation to the bottom. Please check it is bottom. So we are drawing the angle of elevation. So this is a line of sight, what I am drawing here. So for drawing the angle, as you all know, we require the horizontal level. So we will draw the horizontal level, which will be common here. So here PC is the ground level. So this is a horizontal level because the point is on the ground. And now the angle of elevation to the top of the tower, we all know, that is from D to A, we will get the line of sight. Line of sight from D to A. Here you can find. Here from D to A we have, I'll just adjust this. Okay, so I think this is okay. So from D to A we have angle of elevation with this is student is 45 degrees and this is 60 degrees. We have to find out the height of the tower, that is AB. Let's assume this is h meter. Okay. Now here we know that first, after drawing the figure, which are the two right angle triangles we are getting, BCD and ECD. After getting the right angle triangle, which is a common side in both the triangle, BCD, ECD. So CD is a common side which we can use it. So when I'm using the first triangle, that is BCD, then here we can say this is the given side and this we have to common side. So opposite and adjacent. So obviously we'll be using the tan relation. And here we have mentioned tower and building. So there is no need to give very elaborate. So here we'll start with the solution. So we can start in right triangle BCD. In triangle BCD, we are using the tan relation because this is a given angle. This is a given side and this is a required. There is a common. So tan 45 equals to BC upon DC. Tan 45 is 1. BC is given as 20 and DC. So if 1 into 1, here we will get DC and we will get 20 meter. So we got DC as 20 meter, correct? Once we got, now our aim is AB. Let's consider the bigger right angle triangle. So here we have in right angle triangle ACD. So in right angle ACD, we will consider tan 60. That is equals to AC, that is opposite, upon that is adjacent DC. This implies we get root 3. And what is AC? It is 20 plus H upon, here we have 20. So can we cross multiply here? I'll just continue. This implies 20 root 3 equals to 20 plus H. Our aim is to find H. Take this 20 this side. So 20 root 3 minus 20. So can we take common? So can I write H as 20 root 3 minus 20? Yes. Can we take common here? Yes. So we get root 3 minus 1 meter. So this is the answer. Therefore, height of tower 20 root 3 minus 1 meter. I hope you have understood. Let's go to the next sum. Question number 8. Now from this all you must have understood one thing. Whenever we solve this application of trigonometry, as we know, the first thing we find out the objects, then we interpret the figure, we find out the two right angle triangles involved, we find out the relation of the theta with the given side and the one which is common side, given and the required side, or we can say sometimes the given may be common also. Okay, so here I will just reframe this. We can say given, common side, or we can say required side, and then accordingly we apply trigonometric ratio and solve. Okay, let's start with question number 8, following the same steps again. A statue, so statue is object, 1.6 meter tall, stands on the top of the pedestal. So objects from a point on the ground. The angle of elevation of the top of the statue is 60 degrees, and from the same point the angle of elevation of the top of the pedestal is 45 degrees. Find the height of pedestal. So we identify there are three things. Point on the ground is a pedestal is a statue. Now let's go very deep meaning. This is the first reading we got the object. So at least you have to read the question thrice to understand the proper figure. Now a statue 1.6 meter tall stands on the top of the pedestal. Okay. So here according to the diagram, let's find first we will draw a pedestal, and the top of the pedestal. So a pedestal is something where you have a support, and the support it is standing. So let's draw a pedestal here. Okay. So let's draw a straight pedestal, and on the top of the pedestal you can find a statue. So here I find this, and let's take a statue. So let's assume this EB as a statue and my BC is a pedestal. Now I don't know what is the length. I have just taken, and the statue is 1.6 meter tall. Okay. Now there is a point on the ground. Let me take the point as suppose D. There is a point on the ground, and let me take the scale here. So from a point on the ground, the angle of elevation of the top of the statue 60 degrees. So elevation is from the person is raising his head and he is sitting at the top of the pedestal. So first thing for drawing the pedestal, let us make the horizontal level, there is a ground level, right? So let's bring it to the 0 degree quickly. So 0 degree. So here we have from D to C, this is the horizontal level. And now we have the angle of elevation, okay, from the point D. So here we have the point D, the angle of elevation. Okay. So from the point D, you have the angle of elevation to the top of the pedestal. So pedestal, top of the pedestal, okay. The angle of elevation to the top of the statue. No, top of the statue, I'm sorry. Here, that was the top of the statue, 60 degrees. Can you see? So I'm just joining. Beautifully, we are getting this line of sight. Okay. So here we find that from a point on the ground, the angle of elevation to the top of the statue. So I'm right. So this is 60 degree. This is your line of sight AD. This is the horizontal level. Now it is given, and from the same point, the angle of elevation to the top of the pedestal. So here, if B stands for the bottom of the bottom of the statue and the top of the pedestal also. So now we need to join B and B also. And here it is given that this 45 degree. Okay, so I'll join this D and B. So here we have, can you see? Let's take this point. Now here, this angle of elevation is given to be 45 degrees. Correct? So here, once we have identified, now we can solve. So our objects are identified. Figure has been identified. We have seen this is statue, this is pedestal. We have to find the height of the pedestal. So let this be h meter. Which are the two right angle triangles? We can find this figure. BCD, ACD. Yes. Which is a common side, which is again here CD. Okay. So we can find the relation. This is opposite and is a common side. So this is the required and this is the common. So opposite and adjacent is tan. So again we start with the solution. The same funda we'll use. So let's take here, since everything is named, here we can just write let BC equals pedestal, which is height of the pedestal, equals to h meter. Okay. So let's consider in right triangle. When 45 and 60 is there, always go for 45 because we know that tan 45 is 1. So tan 45 here we say that is opposite upon BC. Tan 45 is 1. We want to find h and BC also we don't know. Right? BC is not given. Therefore, we know that h and BC are one and the same. Let's take this one. Consider the next right angle triangle in right triangle ACD. ACD. So let's take tan 60 degree. Tan 60 degree equals to AC upon BC. What is tan 60 degree? Here we have tan 60. I'll just write here, shading the color pen so that you understand. Root 3 equals to AC. What is AC equals to? It is 1.6 plus h upon BC. But we know that BC and h are same. That is from 1. So can we substitute? Yes, 1.6 plus h upon h. You can write here from 1. Let's cross multiply this. So we will get h root 3 equals to 1.6 plus h. So we want to find h. Take h here, so we will get minus h equal to 1.6. So here we have, let's take h common. So when we take h common, we have root 3 minus 1 equals to 1.6. Still our a need to be fulfilled. We have to find what is it. So 1.6 upon root 3 minus 1. Now this is a binomial and we have to find the conjugate of this. This is root 3 plus 1 and again we have root 3 plus 1. Correct? So here when we solve further, let's solve. So we'll just do the rationalization of the denominator. So h equal to 1.6 root 3 plus 1 and here we have a minus b, a plus b in the form of identity. So we'll get root 3 square minus 1 square. So this is nothing but 1.6 root 3 plus 1 upon 3 minus 1 will be 2. So here we'll have 0.8. So here we have 0.8 root 3 plus 1 meter. So what we have, therefore the height of the pedestal, so here we have therefore height of pedestal equals to 0.8 into root 3 plus 1 meter. I hope you have understood this particular sum also very clearly. Again, as a quick recap, I would just like to give a recap session that whenever you have application of trigonometry, students, first when you read the question, first time when you read the question, try to find out the different objects involved. Second time when you read the question, try to find the link between the diagrams and try to draw the figure. Try to draw the figure. While drawing the figure, read at least twice when you read the figure. Okay? When you draw, especially when you draw angle of elevation, so see whether horizontal line and line of sight is there. When you draw an angle of depression, again horizontal line and line of sight is there. So draw that. Third thing, you identify the two right angle triangles. Once you have done the two right angle triangles, then the fourth thing, find out the relation of the theta with the given side and the required side. Required side and the given side, and accordingly you have to apply the trigonometric ratio. If you set a given side, it can be sometimes common side also. Okay, if you have root 3 in the denominator, please rationalize it. If you have root 3, root 2 in the denominator, rationalize. Please keep these following points to get full marks. So let's see the next video for the next sums. So I hope you have understood. Thank you students for watching.